Okay, you don't, again, have to write this down unless it's just something you want to do, because you will have this information on a sheet. I just want to tell you where things came from and make you think about why those things are listed on your worksheet. We are working on worksheet 34. I'm going to make a bank. I like to call it my identity bank. So I'm making a building. And this is its name, Identity Bank. And my bank has a motto. Their motto is, we make even trades. Well, what do you think that means? When you go to the bank, sometimes you might take that big old jar that your father probably has been saving because he hates change in his pocket. It's typically the men that do this, that they empty out their pockets and put their change into some jar somewhere, and then at the end of the year, you know, I've got some of you that agree with this. I see nodding heads because it's just the way it is. I think there's 2 things of it at home in my house. All right, but anyway, then you go do what? Take all that big old heavy thing of change and you take it to the bank and trade it in for what? Is it the same thing? Well, it's equivalent. It has the same value. That's the point, all right? So the point being, you make trades and you just trade out for, and do you want all ones if you've got $150 of change? Probably not. Yeah, you make some different trades. It depends on what you want and what you want it for, right? So sometimes there's multiple different ways that you could trade it in. What my point is that we are going to make trades, simplify some equations and some expressions. And one of the things that we've talked about is some reciprocal functions. So what did you know about the secant of theta? What is it equal to? It was the reciprocal of which one? Not the sine, guys. You better get it straight. It's the reciprocal of the cosine. Okay, the cosecant, remember how it didn't go with the letter of the one that you thought it should? Okay, so I tried to get you to think that so you would remember. So cosecant is the reciprocal of the sine. So the cosecant could be traded for a 1 over sine. The secant could be traded for a 1 over the cosine. The tangent of theta, it could be traded. Wait a minute, I don't want to do tangent. I'm going to tell you that you're not going to really use this one, so it's probably not even listed on your worksheet, but I'll say it anyway since we did talk about the new trig function cotangent theta. It's worth 1 over the tangent theta, but I'm going to tell you that I really don't want you to ever probably trade a cotangent for a 1 over a tangent. There's not too many times that you're going to need to do that. But there will be some other things that you're going to want to know. And that's going to be what the tangent of theta is actually equal to in terms of sine and cosine. Do you remember that the points were written cosine? Oops, I always do that. I always think I made a C and I don't write the C for the cosine. Cosine theta, sine theta. That's how those points were written on your unit circle. The first part was the cosine of that angle that it's located at, and the second part was the sine. Well, the tangent, remember, is y over x. So the tangent could be written sine over cosine. You will want to memorize that. So with that in mind, what would the cotangent of theta be? Cosine over sine. Okay? Those are all very important, except this one's the least important right there of that list. Now, there's some Pythagorean ones. I'm going to draw, let me get view of theta and standard position. This would be your sine, right? And this would be your cosine. Agreed? That's your x value. That's your y value. And what's the unit circle's radius? 1. So, do you remember the right triangle Pythagorean theorem? So I'm going to tell you some Pythagorean identities. I'm going to derive them for you because I want you to see where they came from, and I don't know why I can't write the word identities right now. Okay, Pythagorean identities. They come from this Pythagorean theorem. So what could I write using Pythagorean theorem using this picture? Well, isn't it leg squared, cosine squared plus, oh, by the way, cosine squared theta is the same as the cosine of theta quantity squared. You just write it like this, right? So cosine squared plus sine squared theta would equal the hypotenuse squared, which would be 1 times 1, or 1. This is a Pythagorean theorem identity. Now, you don't need to write all this down, guys. You've got it on your paper even. It's already listed there, but we'll just, so I'm just showing you where they all came from, okay? Now, if I took this and manipulated it, I would definitely not write down what I'm writing right now. I am going to divide everything by the cosine squared. And it's going to give me a new Pythagorean identity. If I can write cosine squared theta. What would this be? Cosine squared over cosine squared equals 1. Sine squared over cosine squared, look over here. Sine over cosine is tangent, so I could replace this with tangent squared theta. And 1 over cosine squared, 1 over cosine is the secant, so I could replace this with secant squared theta. That is another Pythagorean identity. Now I'm going to erase this. And instead, guess what I'm going to divide by? Yay, sine squared theta. And that's going to give me another one. Sine squared theta, sine squared theta, sine squared theta. Okay, so I'm just showing you where these were derived from. Cosine squared over sine squared is, cosine over sine is cotangent, so I could replace this with cotangent squared theta. Sine squared over sine squared would be 1 equals 1 over sine squared. 1 over sine is cosecant, so I could replace that with cosecant squared theta. So now I have all my 3 Pythagorean identities. And we will be using all of this stuff that I have in my bank right now to make trades or to solve things. So let's now go to the top of your paper on page 30, your worksheet 34. And at the top, you see what we've got. Tangent is sine over cosine, cotangent, cosine over sine, etc. Those are everything I just wrote down. All of them. Now, we can do some manipulation with this one because it's so important and so popular and used so much in what we're going to be doing that I'd like you to investigate some other things we could write based on this. What would the cosine squared theta equal if I solved for cosine squared? What would I do with this thing? Yep, 1 minus sine squared theta. So we want to recognize 1 minus sine squared. And by the way, 1 minus sine squared can be factored because it's a difference of 2 perfect squares. We're going to be using that concept as well. All right, and then let's say I decided to solve instead for sine squared theta. That would equal 1 minus cosine squared theta, which is also factorable. Now, I'm going to say this and try to explain one time. I do not want you messing with these. Okay, I want you to use what you have here, and I want you to use them. Like, let's say you have a secant squared in a problem. You can trade it for tangent squared plus 1. If you have a cosecant squared, you can trade it for a cosine. I just don't want you doing the subtractions and trying to remember a bunch of things about those, okay? Just use these, and I'll show you what I mean after we do some examples. All right, moving on. So we did our bank. Now we've already just realized that we have the bank right on our paper. So if the cotangent of theta is 4, find the tangent of theta. I'm going to use something to help me figure that out. I know that they're reciprocal functions, right? Okay, so I know that the cotangent of theta equals 1 over the tangent of theta. So if I set 4 in there, then I'd have 4 equals 1 over tan theta. So I'm going to prove to you that we're going to get 1/4. And I'm just going to show it using identities, okay? If I cross multiplied, I'd have 4 tan theta equals 1. I would divide by 4, and tan theta would equal 1/4. Now, we already knew that. Do I expect you to go through all that? If you were like taking a unit test and all I asked you, what's the tangent? I would say no. But I'm trying to use identities right now and show you some ways that they're used. Okay? So I know that most of you would write real quick 1/4, right? All right. So bear with me on how I'm showing you how to use identities. We still got the answer out of what we did, but it's easier to just remember it's a reciprocal. All right, now, this is not the case as easily with this one. It says if you want to do, you've got cosine theta is square root of 3/2, and sorry for how that's written. Find the cosecant. That's not the reciprocal of the cosine. Okay, so I'm going to use my Pythagorean. I need the sine, right? I need to do the reciprocal of the sine. So I'm going to use the cosine squared theta plus sine squared theta equals 1 Pythagorean identity. I'm going to substitute in the square root of 3/2 for the cosine of theta, and I'm going to square it. And now I do realize that this is one that's on your unit circle, but you're going to find that there are some that are not on your unit circle. Oh, by the way, you need to read this in the very beginning when you're doing problems. What quadrant are we in? Yeah, that would be quadrant 1. So we want to pay attention to that so we don't mess up the positive or negative sign. All right, so we're in quadrant 1, so everything is positive in quadrant 1, all positive. All right, continuing on. Square root of 3/2 squared would be 3/4. So I got 3/4 plus sine squared equals 1. I need to subtract 3/4, so sine squared theta would be 1 minus 3/4. What is 1 minus 3/4? If you take away 3/4 from 1, you get 1/4. Okay, and then you would take the square root. So sine of theta would be plus or minus the square root of 1/4, which would be plus or minus 1/2. But we're in quadrant 1, so what's our answer? We would say sine theta is positive 1/2. And then we would say cosecant then is its reciprocal, which is, what's the cosecant if the sine is 1/2? 2. Okay. All right. Everybody got that? Can I go on? Anybody need this still? Plus or minus the square root of 1/4. Okay, I did square root of 1 over square root of 4. Okay, so I'm going to do the same with this. I want to find the cosine of theta. I know the sine of theta is 3/5. I have taught you other ways to do this. So when you take the unit test, if I'm asking you this question and I don't specify how you have to do it, if I don't say you need to do that with identities, if I don't say that, then you can do it whatever way you like. So if you remember that this is y over r and you find x, you can do the cosine that way. However, right now we're working identities. So I'm going to use my cosine squared plus sine squared equals 1. Okay, so I'm again using cosine squared theta plus sine squared theta equals 1. So I'm going to say cosine squared theta plus 3/5 squared equals 1. Cosine squared theta plus 9/25 equals 1. So cosine squared, never mind, I just wrote something strange looking. So cosine squared theta will equal 1 minus 9/25. Now you can type it on the calculator and hit math, enter, and get a fraction back because you have to keep your answers in fractions. Otherwise, you can say to yourself, well, I could just rewrite 1 in 25ths by writing 25 over 25. Okay, and then that would give me 16/25. I would then say the cosine of theta would be plus or minus the square root of 16/25. And that's positive or negative 4/5. All right, then I say to myself, well, wait a minute, I'm in quadrant 1, so it has to be positive. So you only keep the positive answer. So our cosine of theta would be positive 4/5. Okay. Tangent of theta is 4/3. Find the cosine of theta. You cannot use this identity, and I'll tell you why. You can't use the identity that says sine theta over cosine theta and then tell me that the top is the sine and the bottom is the cosine. It doesn't work. Okay? Can't do that. All right, so no using that for your identity because the cosine of theta is not 3. All right, and the reason that doesn't work is remember that sine is y over r, cosine is, and these aren't necessarily, this r value, if you actually wanted to figure it out, is 5. It's not a radius of 1. That only works for the unit circle in the sense. All right, so what we need to use is something else. So how about the one that says tangent squared theta? Isn't there one that says plus 1 equals secant squared? And if you get the secant out of doing this, you will be able to find the cosine. So I'm going to try using this Pythagorean identity. All right, so I'm going to put in 4/3 and square it, plus 1, and that'll equal secant squared theta. 4/3 squared would be 16/9, plus 1, 9 over 9, equals secant squared theta. 16/9 plus 9/9 is 25/9. And then we're going to take the square root. So it's plus or minus the square root of 25/9 equals the secant of theta. And that gives me plus or minus 5/3. And then I got to figure out what the cosine of theta is, which is the reciprocal of the secant. So it's going to be 3/5. And it's positive 3/5 because we're in quadrant 1. Okay? Am I going too fast or am I going too slow? Or is it okay? Am I going too fast for anybody? No, because I feel like sometimes I'm going too slow, so I don't want to be too slow. It's good speed. All right, I'm trying to go a little faster. All right, between 90 and 180. Where am I? All right, quadrant 2. All right, that means that all students, remember our mnemonic, all students take calculus. So sine is, and the cosecant are positive, and the rest are negative. So I'm just noting that, just so I won't make any boo-boos. So our answer to this problem, since it's the secant, it's going to be negative, and well, there it is, the cosine is negative. All right, guys, what are you going to do right away? What would you probably just do immediately instead of doing all the identities? Flip it. Okay, let's just do that, because I would rather spend more time on ones where you have to use identities. I'm going to need an identity for this one. Okay, so find an identity with cosecant in it, because you're given cosecant and you want to find cotangent. So isn't it cotangent squared theta plus 1 equals cosecant squared theta? You got to get used to using that little chart, so I would be looking at the top of the page and checking that out, right? And I know I have it written down right. Obviously, I've done it before. So we're going to put in 12/5. We're going to square it. We're going to add 1, and that's going to give us the cosecant squared. Oh, I just stuck it in the wrong place. But pardon me, I know what I'm doing. I'm sorry. I knew it immediately. I was like, whoa, stupid. All right, cotangent squared theta plus 1 equals 12/5 squared. Okay, so cotangent squared theta is going to equal, I'm going to subtract 1. I'm going to do this two things at once. I got 144 over 25, and I got to take away 1. So what should I do to make that 1 be a common denominator with this one, with the 144 over 25? Right, 25 over 25. Replace 1 with 25 over 25. Okay, guys, subtract, please. I think that's 119. Yeah, 144 minus 25 is 119 over 25. And I've had some students ask me before, what if there's stuff that's not in the unit circle? Does this look like any numbers on our unit circle? Oh, no, it's not. This is how you solve the ones that aren't on your unit circle. You got to do this identity stuff. All right, so now I'm ready to take the square root. So the cotangent of theta is going to be plus or minus the square root of 119 over 25, which needs to get simplified. We are in quadrant 2, so the answer will be negative. And then we'll have the square root of 119 on top, and the square root of 25 is 5. So our answer is negative square root of 119 over 5. Okay, does anybody still need this? All right, bang. Find the exact value of each expression. Here we go. We're between 270 and 360, so where are we? Yeah, that would be quadrant 4. All students take calculus. Cosine and secant are positive. The rest are negative in that quadrant. So if I'm finding the sine, the answer is going to be negative. All right, I already know that. I'm going to do my Pythagorean identity for the practice. So I'm going to do cosine squared plus sine squared theta equals 1. So I'll start off with 6/7 squared plus sine squared theta equals 1. 6/7 squared would be 36/49. Okay, and then I'm going to have to do 1 minus that. So I'm just going to rewrite this quick so I don't have to rewrite it again. Sine squared theta will equal 1 minus 36/49. So I'll rewrite so I don't skip too many steps here. I will write 1 as 49 over 49 minus 36 over 49. 49 minus 36 is 13. So now I'm ready to take the square root. So the sine of theta is going to be plus or minus the square root of 13 over 49, which is plus or minus the square root of 13 on top, 7 on the bottom. So the answer is sine theta here would be negative square root of 13 over 7. Good. Cosecant, if I want to find the sine, I would just do the reciprocal. They're reciprocal functions, so sine theta is going to be negative 4/9. All right, let's go to 34b, where the real fun begins. Okay, if you thought that was bad, this is really different. This isn't numbers anymore. Now we're just going to simplify stuff. Oh no, these are, once you've done some and you start seeing it, it doesn't look, it's not as bad as you might think. This looks really gross. But don't we know something we could trade this for? The Pythagorean identity, the main one, I said I want you to be able to remember that this would be 1 minus cosine squared would equal sine squared. So I can trade that out for sine squared theta. What could I make a trade for secant theta that would probably be helpful? What is it? It's 1 over the cosine theta, okay? And then cotangent is cosine theta over sine theta. All right, so everything I now have in sines and cosines, and that's usually a good way to go. So I'm going to pretend there's a 1 underneath my sine squared, and I start doing cross canceling. Cosine goes out with cosine. You're replacing them with 1s. Sine cancels out. Oh, wait, maybe you don't like me doing that. So I'm just going to wait a second. I'm going to multiply across. Sine squared theta times 1 times 1. Sometimes when I cross out too much stuff at once, people get confused. And then at the bottom, 1 times sine theta would be a sine theta. So what's going to happen? You can cancel out one of the sine thetas, right? And so you'll have a sine theta left on top. So the answer is sine theta. So all that nastiness there turned into just this. Simplified down to that by making trades. Example 2. Simplify each expression. So when in doubt, rewrite it as the cosine and the sine. The cosecant is 1 over the sine. The tangent is sine theta over cosine theta. The sine thetas would cancel out, replace them with 1s, and that leaves us with 1 over cosine theta. And then I could trade 1 over cosine theta for something a little more simple, so I don't have a fraction. Yeah, secant theta. So you try to make it as simplified as possible. Sine squared over tangent squared. I am not going to rewrite the sine squared theta. There would be no point in writing 1 minus cosine squared there. Not at all. I am going to trade the tangent squared, though, for sine squared theta over cosine squared theta. Now, how do you handle dividing by a fraction? Okay, so you change divide to multiply by the reciprocal. All right, and then sine squareds cancel, and you are left with cosine squared. That is the end of that one. Number 11. Sine squared theta times cotangent. I'm going to leave the sine squared theta alone. If it's already in sine or cosine, usually you will leave it alone. Cotangent, I'm going to rewrite as cosine squared theta over sine squared theta, because I know cotangent is cosine over sine. The sine squareds cancel, and you are left with cosine squared theta. Okay, so those were pretty easy. Now, let's see what we got on the next one. Now I've got cotangent squared theta plus 1. Is cotangent squared theta plus 1 an identity already? Look in your identity bank. Doesn't that equal cosecant squared theta? Okay, done. 13. Now I got to do something a little different. You cannot, do not manipulate this and say that's 1, please. Even though it is. Okay, and let me tell you why, because I want you to prove it. What do you have? You have the cosecant squared equals 1 plus cotangent squared, right? Isn't that what our identity says? So I'm going to trade this for 1 plus cotangent squared theta. Yeah, so if I went and you were looking in your bank, you would look and say, oh, cosecant squared's 1, cotangent squared plus 1. Oh, I guess I should rewrite that in the right order according to your little bank. Not that it really matters that much, but I'm going to do it. Okay, so really what I have here is cotangent squared plus 1 minus cotangent squared theta. All right, sorry, I forgot my theta. And what can I trade the denominator for? That one I'll let you do the manipulation of the Pythagorean triple and just tell me that's sine squared theta. This is what I meant by don't mess around with those other two. Just you're allowed to trade this because you use that Pythagorean triple all the time. I'd like you to prove this. So cotangent cancels out with cotangent though, and all I end up with is 1 over the sine squared theta, which can be traded for cosine squared theta. No, cosecant. I'll let you get me there, Mr. Bulliner. I messed up. I thought you said cosine. Cosecant squared. Gotta blame it on somebody else. No, I'm joking. That was just... All right. So let's see. What do we got? We got a multiplication here. What do you think we should do? Because these look... I don't know. Bless you. What can I trade tangent for? 1 over cotangent? Oh, that would make this... or is it cosine over sine or is it sine over cosine? It's sine over cosine. All right, then I can trade the cosecant for 1 over the sine. And on the bottom, the secant, 1 over the cosine. All right, my sines cancel in the numerator. Leaves me with 1 over cosine theta over 1 over cosine theta. Well, anything over itself should be 1, but a way to prove this is you multiply by the reciprocal of the bottom fraction, and bang, bang, we end up with a bunch of 1s. So the answer is 1. $15. Oh boy, I think I'll just trade stuff that's not in sine and cosine. Okay, so I'm going to leave that sine squared alone. Minus, I'll change the cotangent to cosine theta over sine theta. Trade the tangent for sine theta over cosine theta. The bottom, trade the cotangent for cosine theta over sine theta. And I'll stick a 1 underneath my sine theta and my sine squared theta. Well, I didn't really need to at the top, sorry. Should have left that alone. All right, let's see what we can do. First of all, what happens when we multiply all this stuff? You just prove that they're reciprocals a little bit, or in kind of a way. But you don't just remove that whole thing. You have to replace that whole thing with 1. So I've got sine squared theta minus 1 over. On the bottom, the sine thetas cancel. So all I have left in the bottom is the cosine of theta. Now, our Pythagorean identity, sine squared theta plus cosine squared theta equals 1. If I solved it for cosine theta, cosine squared, it would be 1 minus sine squared. But I don't have 1 minus sine squared. I have sine squared minus 1. So, how about we factor out a negative 1? Wouldn't that turn that whole thing around? Are you with me? Remember how we did that before with our rational functions? So, this is actually, we can replace 1 minus sine squared now with a cosine squared, but it's going to be negative 1 cosine squared theta. You don't have to write the 1 over cosine theta. Okay. With me? And then now I can cancel out one of the cosines. So our final answer is negative cosine theta. Okay, warning. Will Robinson. Everybody ever seen Lost in Space? Probably shouldn't be saying this in my recording. They resurrected this Lost in Space thing that I saw when I was a really little kid. Anyway, and we watched reruns when I was a kid. Never mind. You had to be there. You had to have seen a Lost in Space episode. I'm not going to talk about that anymore until somebody has actually seen it. All right, that's the answer to that one. Let's see what we can trade in here. Will Robinson is one of the characters in Lost in Space, and the little robot says, danger. Never mind. I can't believe I'm saying that. I got to edit this recording for sure. All right, let's trade. Oh, my Lord. All right, secant. 1 over the cosine of theta. Just little things pop into my head, but sometimes, you know, it's just one of those personality traits you don't want to admit to. Anyway, all right. So all I did was trade my sines and cosines out here. All right. Come on. You know what, it's like, just like when something gets said and it reminds you of lyrics of a song and then the song pops into your head. Okay, it's very similar. All right, these have the same denominator. So what can I do if they have a common denominator? This is kind of dry stuff, so I was trying to throw a joke in here and there. What's that? Combine what? The what's? The numerators? Yes, ma'am. All right, 1 minus sine theta over cosine theta. What it was that I was talking about danger. You can't skip steps. You have to show them. So Those of you who, want to go, well, this equals that. I mean, you got to show why, right? That's what I'm showing you. And this is the kind of thing you have to do. You have to show how you get where you get. You cannot just get there without showing it. All right, so multiply by the reciprocal of the bottom fraction. So all these steps must be present when you're showing your identity stuff. Now, what happens when I multiply the top and the top? I get cosine squared theta. And on the bottom, I get 1 minus sine theta. Now, we are not done. What can I trade this for? Cosine squared. It's 1 minus sine squared theta. Now, here's where you will be tempted to make a mistake. You cannot cross out the signs, and you cannot cross out the ones. We have to factor the numerator. It is a difference of squares. That is 1 minus sine theta times 1 plus sine theta, all over 1 minus sine theta. Well, now I can cancel out the 1 minus sine thetas. And what am I left with? 1 plus sine theta. That is the answer. Did you ever see little dots like this when someone concludes something? Therefore, yeah, that's the final answer. But anyway, you don't have to write that. Whoa! One more. Makes your brain hurt? Oh, come on now. All right, let's do some trades. Tangent is sine theta over cosine theta. Cotangent is cosine theta over sine theta. Plus 4 times sine theta. Cosecant is 1 over the sine. Plus 2 times the cosine theta times the secant is 1 over the cosine of theta. What's going to happen next is pretty nifty. There's a blast from the past word. Nifty. All right, this is all 1. So 3 times, we got 3 plus 4 plus 2. It was. Your assignment is 35 AB.